Good afternoon, my name is Brian with the Automotive Training Group. Today I'm going to show you how to do an oxygen storage capacity catalytic converter test. And we use this test to verify the cerium storage of the converter. Cerium is the component in the converter that the OBD2 system is actually testing for. Earlier systems use switch rate testing, which I will demonstrate in another video. For this video, we're going to strictly demonstrate oxygen storage capacity testing. I have with me today a 2016 Jeep Cherokee. Newer vehicles with air-fuel ratio sensors use oxygen storage capacity. If the computer uses it to set the code, I can use it to test for the code. In order to do that test, what I need is a scan tool that I can graph with. Here on the screen, I have my two front O2 sensors and my two rear O2 sensors. I have bank 2 up top, bank 1 at the bottom. So I'm going to monitor the sensor activity once I've got the converter warm and the vehicle's warm. And what I'm going to do is I'm going to add propane. In order to add propane, I'm going to use a propane rig, and I'm going to have to find a place on the vehicle that I can inject the propane. And what we're going to do is we're going to watch all of my O2 sensors read rich. Once they've all read rich, I'm going to take away the propane, and I'm going to watch my front sensors drop, and I'm going to see how long it takes for my rear sensors to drop. Ideally, I'd want to use about 20% fuel trim change to do this test. I'm not displaying the fuel trim here because I really wanted to show off the O2 sensors. And I want to demonstrate the theory of the test. So what happens is when I go rich, I take all the oxygen out of the cerium. And I do that by adding propane. Once I take the propane away, I've now created a lean condition because fuel trim will have been taking away fuel going negative. And I'm going to see how long it takes from the time the front sensors go lean to my rear sensors go lean. That is the amount of storage I have in the converter. So I want to see two things here. First of all, I want to see a long time of storage. Preferably I'm going to see so much storage that actually my front sensor is going to start switching before my rear sensor ever drops and about 20 seconds go by. If I have less than 2 seconds of storage between these two events, I know it's bad. Between 2 and 7 depends on the manufacturer. GM says 1.8 seconds is minimum. Hyundai says 4.5 seconds is minimum. So it really comes down to the manufacturer. So what we want to do is we want to look at that. The other thing I want to do, and the great thing about having two banks, is odds are I'm only going to have a code on one bank. I have a 420 code for bank 1, and bank 2 doesn't set a code. I can go and look at my mode 6 data, and I can see that yes, bank 2 tests really good, bank 1's failing. So when I do this test, I should see bank 2 be really good, bank 1 would drop really quickly. That would confirm the code I'm getting. If they both drop at the same time, newsflash, it's not the converter setting the code. Time to check for exhaust leaks, time to check for O2 sensor faults, things like that can affect it, because what we're doing here is we're isolating the converter on its own. We're going to test it using the propane. We're going to measure the cerium, which is the element that actually sets the code, and see if I have enough in there. So let's go over to the vehicle, get the cover off, and find a place to inject propane. So I've got the cover off, and I'm looking around, and I have a couple different places I could go. I could go in the PCV system. I might be able to go where the brake booster goes in. And on this vehicle, I have the purge solenoid up top, and right next to the purge solenoid is a vacuum line. A little twist, I can pull that off. And when I pull that off, everybody goes lean. And if I plug it back in, we can see my front sensors went rich, and it took my rear seconds a little bit longer to go rich. So I don't want to do my OSC test this way because that's not how it's designed to be done. So what I want to do is I actually want to drive it lean. Now I mentioned 2 seconds to 20 seconds, but if you notice, I'm not looking at seconds here on the screen. I'm looking at frames. These are frames of data. So these are going to vary by how fast my refresh rate is back to my scan tool. So what I want to do is I want to convert these frames into seconds. So I can do that a couple different ways. I could use a stopwatch on a cell phone if I was younger. I'm an old guy. I still know how to count 1 Mississippi, 2 Mississippi, 3 Mississippi. Keep in mind, we're not talking milliseconds here. I'm trying to get a general idea of my converter's health. So if I take this and I see this cycle at 3200 and I start counting, 1 Mississippi, 2 Mississippi, 3 Mississippi. I can see I get about 3 Mississippis in 12 frames. So that's approximately 4 frames to the Mississippi. So 20 seconds is going to be 80 frames. So now I have a rough conversion rate. Again, I'm not splitting things in milliseconds here. I'm going to be able to see real quickly if something's really good or really bad. So what I'm going to do is I'm going to disconnect my vacuum line and hook up my propane. And what I want to be careful to do is not inject too much propane. So I'm going to hold this down, slowly crack this, and watch everybody go rich. I've got the cerium out. I'm going to let go. My fronts drop at 36.95, and my rears, as you can see, are still not dropping and never did drop. We started switching again up about 37.20. So let me freeze this. I can bring this over, and we can see here, here's where we drop down. I let go of the propane, 36.95. I come over here, I'm at 37.20. That's where my front sensor starts going back in fuel control. Again, we know from experience it's 3 seconds for every 12 frames. So that's about 25 frames. There's 6 seconds. And we can see my rear sensor never did go lean. My cat has plenty of storage. I could hold propane on longer and possibly get more time here where fuel control is not fighting me, but this is a newer vehicle. It's got a lot of fuel control. The point is, I got 7 seconds here. I can see these are both dropping pretty equally. I don't have an issue at the end of the frame. I was at 725 and 705. No one's dropping down. We're looking good. I have 2 good cats here. Don't dwell on trying to make something look perfect. What we're trying to do is get information. Spending an hour to get information that we got in a few seconds, I'm not going to be any smarter. Don't worry about making it perfect. Worry about getting good results.